What's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Join me every week. It's mi hermano, Pedro.
Good morning, everybody. I'm Pedro as Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
Yes, sir. This is the show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome to the show. It is episode 532. It is Wednesday, June 24th, 2026. We are hanging out in the Adafruit Discord server. So if you'd like to join us throughout the show, hit that link up there, discord.gg/Adafruit. We'll check in with folks, say hello, answer questions. We're streaming on all the usual networks, Facebook, LinkedIn, YouTube, Twitch, and X. So if you want to hit us up on there, we can bring in the chat or a question. And we have a new project that we dropped this week. We have some prototypey stuff, shop talk stuff. We got a Timelapse Tuesday. We got a coupon code that we'll talk about in just a moment. We have phone calls. We're doing a live show. That's funny. So let me go ahead and jump into adafruit.com/free, and we'll get you that coupon code in just a second here. adafruit.com/free. These are the freebies that get automatically added to your cart. If your order is at $99 or more, you're going to get a PCB coaster with that golden Adafruit logo. Let's say your order is at $149 or more. Well, you're going to get that PCB coaster plus our lovely KB2040 microcontroller featuring the RP2040 chip. Lovely keyboard driver is what we call it. At $199 or more, that's the top tier. You're going to get the PCB coaster, the KB2040, and free UPS ground shipping for continuous USA only. All the details are at adafruit.com/free. These get automatically added to your cart. And while you're at checkout, why don't you take advantage of our coupon code, gets you 10% off your order, Navigator. That's right, Navigator will get you 10% off your order. Coupon code expires in 24 hours, so you have some time to take advantage of it. And we appreciate all folks that use our coupon code during the show and after the show, because it's good for the next 24 hours. So, lovely. Over on at Adafruit's Discord server, we're hanging out in the live broadcast chat channel. We know it's summertime, so some folks are off, and that's cool. So if you're watching this on the archive, hello. And
good morning.
Good. All right. We good. If you want to jump in.
Good afternoon. All of the times of day. Yes. Let's go ahead and jump into this week's project release. This week we are launching the Minecraft-inspired GPS compass. On my screen over here. You can take a look at it. We've been showing it off for a couple of weeks now. It's fully built. It has the waypoints. It has the compass mode with a bunch of the cool features like the themes, the magnetic declination edits, the units, the theming, what else do we have? Self-calibration. I thought was super cool. You don't have to input all of the numbers. It does it for you. Has a nice little walkthrough. That is, of course, Minecraft themed. You have like screen rotation, and then of course the case is all dual colored. There's 3 colors on here to match the Minecraft blocky theme. Fonts and all that matches. Got a little help menu. There's so much in here.
Yeah, fully featured. It's probably our most packed GPS compass.
Yeah.
So it's really cool. It's got battery monitoring, which is really sweet.
Yeah. Battery monitoring. You have your little help menu here. You even have your guide on how to set up your magnetic declination. UX here that helps you navigate as well. So you can have the button control to close out windows or hold to save your location. So if you press and hold up here on the header, I'll ask if you want to save the location, and it gives you a canned amount of categories. We were using this during summer camp, so we were able to save a couple of spots. Favorites from Minecraft, like the Nether, Mine, your Stronghold, Outpost, and Castle, Portal, Spawn, of course, Home.
Your spawn point. Yep.
I was able to get some GPS connection satellites acquired last night testing, but of course not while I'm going to be demoing.
Right.
So because we're indoors, it'll be hard to get that to demo where any of these locations are. The locations save into a JSON file, so it's just a text file with the longitude and latitude locations. You can paste those into Google Maps, and it will pinpoint exactly where the locations were saved. So it's super cool to be able to go back and look at all of those.
Very cool.
Sometimes it was able to save during overcast, cloudy, rainy days. Other times it was not. When we're under trees and the structures, it was not able to acquire locations. So your sky may vary on when you're able to get it. But of course, the compass mode works all around. And you can see here, it is nicely themed to the way that the needle looks like inside of Minecraft. Using the photo zoom to animate, and it has some easing and smoothing on the way that it rotates around. It's so satisfying.
Yeah, it's fluid. Very nice.
It's some fluid. The header, or the footer down here shows you where you're facing, and additional info for whatever mode you're in. Have your scroll up, your scroll down. Actually, let me use this pen here. So
there you go.
Isn't blocking. Oh, the other cool thing that we have not done for a TFT touch screen is we added an anti-glare film on here that's usually used on iPads to make it more visible outside during the day. Cuts down on the glaring and the brightness.
The reflections. They're nice and diffused.
And it also protects it. I noticed I nicked it just a little bit when I was trying to use the calipers to measure the cutouts for this, when I was adjusting the header and the footer, to make sure that everything has nice padding around the UI.
Yeah.
Else, you can just switch here, the units to the people overseas. We can go to, and that lets me also demo the way that the touch works. You select to arm it, I think is what Claude called it, and then click again to actually fire off to activate the option. I can demo it by looking at it there. Let's see here. Bam. Go to kilometers. And then the declination works kind of similar. You arm it, and then either the left or the right, wherever you touch, is where it will adjust the if it's going like to the west or to the east, to adjust your offsets for that. Same with the rotation, and then your calibration will highlight red to make sure that, are you sure you want to go through that screen?
That's clever.
And even when it jumps you into that screen, you'll have a second opportunity to either go through the calibration and the walkthrough, or to cancel it.
Okay. Oh, that's cool.
And we're using the boot.py file to do the read and write, and then save all of the accelerometer and the gyro settings to the device. So they're all working together to be able to apply which way you're facing to the needle.
Yep. Very cool.
So what else I can demo? I wanted to open it up, but since the guide's already done, we can just look at that without me sitting there. I'm gonna unscrew everything. So we have the stemma push button, we have a little slide switch, and even the way that those are hooked up, we modified a little socket to jumper cable to plug everything in to the spare socket headers that are on the TFT FeatherWing. And when you plug in the Feather, there are an additional set of socket headers on the outside of the Feather. So that's super cool that you're able to use all those additional sockets. So I guess without further ado, let's go ahead and jump into the guide.
Okay.
Pretty easy in terms of the construction, but just the way that it's assembled is a nice circuit sandwich. Everything is so compact on there. Go to the right screen here. Do a little scroll here. A lot of the items or components that are required are in stock, so that's good. Except the TFT. It was in stock this morning.
There was 2 in stock yesterday.
Yeah.
I was pondering getting one, but we'll make more.
Definitely got to pick those up. I had the old ones that do not have the stemma connection.
So the V1s, yeah.
Yeah, so definitely got to make sure those absolutely help for this, because then the other stemma connection faces upwards, and then would have definitely messed with the orientation, the way I'm able to completely sandwich everything together. So that helped out so much, having that on the side. I have 3 boards here that are helping do the GPS and the navigation of the needle. And then another set of all of the cables, all of the jumpers that are required. There is a
oh wow, we're at a slide switch.
Easy construction. Yeah, it's easy construction, but it definitely requires a ton of little ancillary cables and headers and socket headers to connect everything together. So it's simple, but there's a ton of parts. And then, of course, all the screws here that are required. You got your M3, your M2, because of the battery monitor, of course, has to use a smaller size. Here's the way that everything's connected. This is what makes it simple. The stemma QT cable does a nice job of being able to daisy chain everything into the display where the feather is plugged into. And then the way we're sharing the ground connections, we'll go over that. I'll skip over the Circuit Python because it's just the mirrored page. And it's pretty easy. It's a drag and drop. I didn't have to do any updating on the radios since there is none.
Oh no, what happened?
What did I click on?
Oh, the code page.
Oh, let me see. Oh, I'm not going to be logged in. Could you?
No, you're good. All right.
Because it's going to ask me for verification and all that.
Oh no.
Just skip that, but it's like 8 different files that had to be split up to comply with the way that the CLI on our GitHub is set up. But it does a nice little walkthrough of which each editable file you're able to update, like the smoothing on the needle, or if you want to change the colors, or the canned save locations. So all that is there. We'll skip to the 3D printing page, and that has all of the files that are required to print. It's mostly like framing that are fastened to the back of the TFT display. Even that was a nice, simple way to attach all of the components. Looks like you already got the code page now.
I'm trying to troubleshoot it while you're going through it. We'll have to just reach out to the dev team because it's something in the back end. I can't quite troubleshoot why it's not working. Everything looks good on my end.
Yeah, today's the day for things to be down. I wanted to show off the CAD files for this too, just spin around all of the components in 3D. Yeah. And Fusion is also having problems with their servers, so
yeah.
Show that. But here's a screenshot of what it looks like. You can get all of the design files that we used for this, and the painted model for the case as well. So the M3F file is already set up for you. So if you want to change the color for this, that is available as the M3M file or 3MF file, and then the Fusion can export to a step or any other type of file. There's so many file formats you can download and get those. And then the source files, the GitHub, and of course the fritzing files are also available, so you can grab those if you want to use that. Yeah, bummer. I wanted to spin around and show all the way everything's nice little sandwich, how thin you're able to make everything and completely compact with so many components. We can kind of show it off here in the assembly. So to start off, we soldered short headers to the feather. This is the RP2350. And I don't believe longer headers would work on the feather TFT, because even with the short headers installed, it has like, I don't know, like a millimeter or millimeter and a half that is still exposed. Like it doesn't seat all the way in. So yeah, so definitely use the short headers.
Okay.
A regular standard size one would still, it would pop out of there. Even in the model, I had to add sort of a holder so that when you plug your USB in and you accidentally move it up or down, it doesn't unseat it from the sockets.
Oh, I see.
Yeah, that's how shallow the header on the TFT FeatherWing is. So you're absolutely going to need the shorter headers for this.
Okay.
The way that the sensors are laid out in the frame, you definitely want to reference the position that the stemma ports are facing, so you're able to lengthwise reach with the 50 millimeter long stemma cables. And of course, to keep it all nice and clean too, so you don't have to like coil up any of these wires. There's plenty of room, or just enough room, even with the feathers seated in here. That's what that looks like. Here's where you can start seeing the circuit sandwich form. This whole frame mounts to the Feather TFT wing. From the front here, we'll use the M3 by 6 millimeter long screws. So the bigger screws will be used for that. And then the anti-glare film, here's the one that we used. This is for an iPad. And the reason why I went with this one specifically is because this anti-glare film does not have adhesion in the center, so it's easily removable. The adhesion is very light, and it's using like suction too to hold on. So if you ever want to remove it or reuse it, it's like non-destructive. The light adhesion is on the black rim of this, and you can cut that down so that lines up with the TFT here.
Oh, I see.
Bezel around where the TFT is, where there's nothing visible. There's no graphics going to it anyway. So that's what we're using to adhere it. And it feels like paper. It feels nice and smooth. It has like a matte feel to it. We'll be definitely using this on more TFT displays that need to be outside to minimize all those reflections.
Very good.
From here, you'll start connecting all of your stemma QT cables, and definitely take note the way that I'm routing these like underneath the frame to sort of tuck them out of the way. For the battery frame, it slides into a like a holder for it, and then right on the holder you can add more additional components like the battery monitor. This is optional, so if you don't need it, if you don't want to spend the extra, what is it, like $5 I think for the max, I forget the numbers, the battery gauge monitor. Definitely useful though if you have a a gadget that's outside. It's good to see the fuel gauge on it. I can see why you couldn't, or Lamar wasn't able to fit it in the board. There's just so much components on there. Probably the display, what is it, the HTSX display, the ribbon cable. We're using a tactile button to save our locations, new like actions in the menu. So that is also able to be mounted to the LiPo display, or the LiPo frame. Here's a quick little look at how everything looks when it's all connected before you complete the sandwich. It's got a lot going on here. There's a ton, but I like how it's nicely laid out. Again, with the wiring, you're able to tuck it underneath the board here to give it space to breathe, since it will be all compressed. Here's what we were talking about with the ground socket splitter. So I took a socket header and cut off where there's only 2 sockets, and then soldered those 2 pins on the other side together. Shrunk it, and then on the other side is a header pin from a jumper cable, using the silicone coated ones here, so it's nice and bendable and it's resistant to heat. And then right at the end, you just bend it at 90 degrees so it's able to plug into the socket and then get out of the way. So that is a nice technique. I have not used that for doing the sharing ground through a socket. And then the slide switch, I wanted to do the same thing. And luckily, the jumper pin to socket ends work perfectly for holding on to the slide switch. So I didn't have to solder that either. All I had to do was just clip off the third end of the pin on the slide switch.
Right.
That plugs in beautifully, has a nice grip. And then for the stemma cables, we have these stemma PH stemma cables. Those have the 3-pin on there. They're more chunkier. And all you got to do is just cut off the center power, since we're just using signal and the ground for that. And on the white one, that's going to be the signal that is, again, bent at 90 degrees, so it can plug right in. The ground is going to plug into that splitter, so don't have to bend that one. And here's what that looks like, nicely plugged in. So those plug in here. These are both the grounds being plugged into. You can kind of see it right here to the ground socket. And here's why we have to bend it at 90 degrees, so it lays flat against the board here like this. And you can see we did it also to pin 5, which is the button, and then the enable for the slide switch. That allows us to turn the whole circuit on and off, but still allows you to charge the battery. Tactile button. Here's how that plugs in. Again, utilizing every piece that I can mount something to. There's a one screw mount that it goes into, and then this slot right here is what the entire PCB for the button slides into. And here's what that looks like when it's slid in, and this is to prevent it from rotating around. So we have a nice little cutaway right here, right inside the frame.
All right.
So yeah, that's a nice technique of when you only have one screw mount, you can't get to the other side because that's where the one of the sensors are. So there's absolutely no space there. But if you use a holder that's built into the frame itself, it's out perfectly. You can just plug those in, and then everything is fastened to the frame, the battery frame and the main sensor frame. Here's a better look of how that seats in, and then you have like this little extrusion on the frame itself to allow it to seat in, and then have a wall where it's like cuddling it, holding it in place. Everything gets seated into the case here, right along the USB cutout. And here's that thing that I was talking about. It's sort of like a wall that the USB port plugs into. And again, this is to prevent when you plug in a cable and you accidentally move it up or down, it prevents it from the board moving and unseating itself from the socket inside on the TFT. That just speaks to how shallow the sockets are on that. So you definitely, again, you need the short headers for that. Here is the part, Noah, that you made for the slide switch. I just molded it right, or merged it right into the lid.
Tried and true, side switch holder.
Exactly. I didn't even have to test it. I already knew that it would fit because we've used it so many times. It was nice to just merge that in there and align it to where there's free space inside of the case. And then we have these additional walls here, and they helped prevent the LiPo from sliding out of the frame. Right. So there's no rattling; those hold it up against there. And then there's another wall behind here that pushes the entire assembly up against the USB port. So there's no rattling around. It's all like held together with walls that are positioning. I have it in the text, but I forgot to mention here the button cap for the stemma button has to be removed, so it'll fit inside the case. And then this is just showing realigning it and reattaching the button cap to reattach that after everything is fitted inside of the case. And that's it. Nice little assembly. the wide angle lens makes this look smaller than it is, but it is pretty small. And even the depth of it is not too bad, given all of the different components that are in there.
Yeah, nice chunky battery.
Yeah.
Very
It's
cool.
a 2,500 milliamp hour battery, so it'll last you like 2 days. Inside of the usage page, there is a whole walkthrough here on how the UI works, how the taps for the buttons work, the gestures work, the boot up calibration, how that walks you through.
The user manual.
It's a user manual.
Cool.
The battery functions, the alerts, the side buttons, navigating waypoints, how to edit that. Oh, how you can delete waypoints. There's a nice little trash can icon on the opposite side of the text.
Cool.
Same thing, you'll arm it and then click again to delete, so you can add more. All your settings, info guide, and then of course the recalibrating on the field. So it was all tested while we were out camping, so it works beautifully. That's how a lot of the user experience design was influenced on this. Me taking it out and seeing what worked, what didn't work.
Did the battery last the whole trip out there?
Oh yeah,
4 hours. Yeah,
it lasted like 2 days.
Oh, okay. Yeah, it's what I missed. With it's a 2,500. That's the biggest
2,000.
one?
Yeah, 2,500 milliamp hour.
Okay. Yeah, very good. Cool. Yeah, it's great to have that monitor on there for sure. Especially if you're using it outdoors, you want to know how much juice you got left.
Yeah. That was
all right.
I wasn't gonna add it, but then I thought that it was built in, but most of the feathers do have it built in. Like I think the prop maker has it, right?
I don't believe it does. Just look at the specs on in each feather. A lot of the ESPs I think do the ESP feathers. Yeah, I think the TFT feather reverse one of those has it. But yeah, very cool. All right, we got a couple of questions. One from Tyeth on Discord. Really easy one. Pedro, did it help? Did that anti-glare film help with photography?
Absolutely.
I imagine so. Yeah. Yeah, it's good. It cuts down the reflections because that's hard to block.
Yeah, you can kind of see in the video where I didn't use it, like the very first 2 shots.
Oh, really? Okay.
The reflections, yeah. As soon as I like turn out of the shadow, it is just like you see the camera lens in there, and it's super distracting. You can't focus on any of the UI. It looks super busy without. Because I use a polarizer on here, you do have to take care of how your polarizer is adjusted so you don't have like that moire effect.
Oh, right. Yeah.
On the screen. So that's the other problem. But you won't get as many reflections. You can kind of see here.
Yeah.
If I didn't have it on, it'd be way worse. Like you wouldn't be able to focus on any of the UI here.
Reflections.
While we were getting ready for the demo here, we did spot a bug that I have to push out on GitHub on the way that the button function is. It's blocking the told you what was the monotonic timing on the button press for the GPS blocking. I got Claude working on it right now. I will an update. The save menu isn't coming up on the code that's up there right now.
Yep.
But I had to, we were talking about this earlier. We had to split the one code.py file into 8 different files because of how giant it was. I think it's like 3,600 lines of code. So I had to break it down to like 100 lines of code each because of the way that the GitHub CLI is set up. Wants to keep it more manageable.
Okay.
But I told Claude, hey man, as soon as it starts getting big, start splitting it up because I'm not going to stop adding features. It's only going to grow from there.
Okay. Cool. We got another one. Let's see here. Just a comment from Relic SC. Thank you for the comment. Great job on the compass. Looks really professional. Yes. Same thing with Dicey Mangoes. It's the same thing. Excited to build it. And then a question also. I asked a couple years ago some help with some accelerometer for determining if my washer and dryer cycles were complete. I'm grabbing a Feather ESP32S3 and an LIS3DH breakout board. That sounds like a good combo. Yeah. You could try posting up on the Adafruit Discord, of course. A lot of folks are there.
I
people
remember
on
somebody
staff.
came on. Didn't somebody come on the show and tell and show that exact project where
Sounds like it. Yeah, I think so.
Using like if it stops shaking from the washing machine, like if it stops detecting motion to send an alert.
I wonder if you could do that with Whippersnapper, kind of like a no code, just maybe. Yeah, that's good. Or you could ask, you know, if you're okay with using something like Claude or what's the other one? Was it Copilot? One of those, or even ChatGPT. You try asking them.
Yeah, that's Codex.
Yeah,
Lamar uses both Codex and Claude.
Yeah.
So it pins them up against each other and says, "Hey, Claude said this was easy. Why aren't the Claude?"
Right. Yeah.
They duke it out.
Cool. All right. Some suggestions there.
Just took like 3 weeks, so been going to sleep at 2 a.m., waking up at 6 a.m. To finish it.
Yeah.
Not only was it the printing and the designing, but actually going out in the hot 96-degree heat with the kids, like all day camping, multiple days.
I'm glad it survived the
real world.
Yeah, as long as you're not in direct sunlight, the PLA is not going to melt, so you're good there.
Yes, although I did have it out in the sunlight for a lot of the shots, so it was able to survive. We're using
it takes a couple, maybe an hour, and it would deform.
It needs to be in direct sun, and
because
and I think it has to be like multiple days. A lot of the pot planters that I printed in black, so algae won't grow inside the pots. But these are in phase mode, so it's like one wall. Those have melted on me when they're in the direct sun.
Yep. Oh, and if you wanted to pick up parts, you can use Navigator as the coupon code and get 10% off. So that's good on all things that are in stock. So that's good. All right, let's see. I think that's everybody's questions. Very good. Very good. All right. Sweet. Yeah, we'll ask Learn Dev team about the code page.
Yeah.
It's for some reason it's given a 501 or 404, one of those 500 error. We'll take care of that. It's the first day of it being published, so we'll see what's going on there.
Oh, I am logged in now.
Yeah, I know. I tried to troubleshoot it while you were talking, and everything
was published in the back end.
The only thing I can
I can show it. Let's see.
Well, of course, but the one thing I can see is that there's basically all your Pi files are embedded content. Maybe there's an issue with the project bundle with having multiple. Because imagine having
which bundle do I build?
Yeah, which bundle is it gonna grab, right? I think the bundle only works with like the code.py, and then it'll just grab the rest of the Python files because it's a part of the bundle, right? So you might have hit an edge case. I'm not sure.
I thought about that too. I was like, oh, how's this gonna work? I can't think of any other project where it's split up.
Right.
Sure, we have projects where there's a menu system, right?
Well, yeah, but they're not as
it's not
there's not multiple files. I know there's like, it's gonna grab your settings.toml if there's something there, or if there's a JSON file, it'll grab that. Of course, assets like MP3s and bitmap, fonts, all that stuff's a part of the bundle. So
I don't know.
It makes sense. Oh, why did you add that? Yeah, that's you might want to just.
Is that why? I don't know how to.
I mean, that's the only thing.
It's in the GitHub.
Yeah, the project bundle will have all that.
Yeah, you can just go to GitHub and grab it from there. Minecraft / there it is.
Yeah,
you could subscribe to this to
the boot file
get
too.
Updates. Yeah, to get updates before the guide launches.
Yeah, you are doing another push, so.
Yes.
To fix that blocking button. Okay.
It is I think it's mcconfig and CodePy that need to be updated.
Alrighty. All right. Well, you get that. I'm going to set up my shared screen for my
and then Fusion is still down.
Topic. Yeah, the Fusion website. Right. I'm about to load Fusion, the desktop app here.
And I was gonna say how. Oh, okay, you got it. I'll transition into.
Yeah, of course.
I use the Fusion AI to build something.
Yeah. I'll do that, and then you can jump back into the shop talk segment. Yeah, so a lot of folks know that I generate 3D models of Adafruit breakouts using Lemore's Eagle board files. And typically I would use kind of this older legacy method of doing that. That's where you would use Eagle 9.7. You open up the board, there's a manufacturing tab, and it lets you generate a 3D model of that Eagle board into a Fusion 3D model that shows up, and it has components, and then you manually map those components. So it's been a little bit now that the Eagle standalone desktop app is basically end of life. It's no longer being supported. I can't even open it anymore because it's the way Autodesk wants it. Not a fan of that, but that's the way it is. So I use Fusion, and Fusion has built-in Eagle into Fusion as a whole complete package, right? So I went through on Friday and just kind of relearned what the workflow is for getting an Eagle board file and schematic and turning that into a 3D model, the new modern way that's all built into the Fusion workflow. So I was able to create one. Here is the PCM 5100, which is a great I2S DAC for doing I2S audio out, because I'm going to use this in a project. So I will be able to continue making and generating 3D models of the Adafruit boards that were designed in Eagle. There's been some talk with Lemore. I don't want to speak for her, but she has most likely going to move on to a different piece of software. KiCad is open source. She's looking at that. But I still want to be able to open her Eagle, her older Eagle board files and generate them into 3D. So I learned how to do it. Basically, you import, you open the board, so you can just open any board. It's like this one here. It pretty much is Eagle. It's not one-to-one, like it's the same kind of tool set, but things are just moved a little bit around. Panels are a little bit different. The tools are pretty much the same, but yeah, things are a little bit different. So this looks just like Eagle, right? It's pretty much the same. So there's a button up here that lets you switch to the 3D PCB. And when you go there, it just shows the board, but there's no components. So it took me a little bit to relearn how to get an Eagle library into Fusion. And then you turn that into a managed library, which basically means you're just pushing it to their cloud service so that they can do whatever they need to do. So once I was able to get Lemore's libraries, I was able to import those, create them into a managed library through the Fusion workflow. And then from each component, I'm able to, when I say component, I'm talking like the footprint, like a resistor, packages like capacitors and mechanical stuff like this TRS jack, audio jack. All those things are built into Lemore's libraries. So I'm able to create those into, convert those into managed libraries, and then map the 3D models that I already have to those parts. And then in the Eagle thing, like let's say this component here, I'm able to right click on it and say swap library, and then swap out that library with my new managed library that has those linked 3D models. So that's how I was able to create the 3D model now. And it's a lot more detailed too. So previously it was just a silk screen, the top layers, but now you can see here that there's like dedicated layers for the board, which is really interesting. So you get like really, really nice 3D models of the Eagle boards. So you can see here, this is the copper layer, and it's actually 3D. It's got the right thickness and everything, and it has the right materials as well. So that's pretty cool. I hit the board, but there it is. A little bit of a learning curve for me, but look, it says out of date because it thinks I did something, but I didn't do anything. I don't think.
It's when you turn things off and on, the visibility.
Maybe, yeah, it'll go nuts when you turn things off and on. Yeah, it'll be like, save it. It's like I didn't do anything. But either way, I figured out how to do it. Very good. Excellent. I will continue to generate the things as I can get to them. There's a bit of a backlog, and I just made this one because I actually really needed it for a project. But nice to know that that's not completely dead, since I still continue to use Fusion. I can continue to generate 3D models of the boards if they're made in Eagle. You also notice the the fonts are like nicely rendered as well. So it has like vector fonts, and that looks really good now. So that's good. So yeah, there's some good updates there. So I will continue to make the boards, and I think there's a new one too that's coming out in the shop. We'll see. See what happens. So what I'm using it for, real quick, I'll just talk about it. I'm working with Liz. I'm collaborating with Liz Clark on a project that she's working on. It's a bit of a suggested idea from Lamore. It's a chiptune player that uses the Feather RP2350 as the brains, and the display is the one that you use, Pedro. It's the TFT FeatherWing, the 3.5-inch TFT FeatherWing V2. So the idea here is that we're going to have this DAC here connecting to the Feather, and the Feather is going to have some CircuitPython code that allows you to play VGS video game music, or VGM video game music files, and play them kind of like a chiptune player. So the songs will be loaded on the micro SD card that's up here. You have access to it here, and then I'm going to add a little button here, or a little slide switch clip that will allow you to turn the thing on and off. It's not going to be battery powered. It's going to actually connect to the USB-C and just be like a little desktop music player. But the idea is here you'll have a little cutout here, a little circular cutout for your audio jack, because it doesn't have an amp. You know, it's only it's a DAC, but it doesn't have an amp to power speakers. So we're not gonna have any speakers in here. The idea is that you plug your headphones into it, and we're just gonna keep it really simple. Just 1, 2, 3 components. You know, you still got to wire this up, but it'll be this vertical, you know, portrait mode kind of thing, and it looks like those old school arcade cabinets, because that's the theme, right? And you can get video game music VGM files from the internet. I think Liz has like Pac-Man and some other fun ones that sound really good. It's using what is it called? It's using Synth.io to actually play it through Synth.io and the I2S audio out, CircuitPython, all in CircuitPython. I think this was inspired by an ESP32 Arduino kind of project. And so our idea is to like make it, package it nicely, use the Adafruit parts, and of course use CircuitPython and some of the built-in libraries to make this really cool chiptune music player. So that's going to be neat. So that's what we're working on there. But yeah, in order to get there, I had to figure this out. Can I still make components? The answer is yeah. You just gotta use those managed libraries. All right, and that's basically my whole spiel there. Don't want to get nitty-gritty. This isn't a tutorial or anything. It's just a little look at some of the workflows that I had to figure out.
I had a question here on the project that you may have already answered.
Yeah.
32? Yes.
Yeah, it's an ESP
Inspired.
project. Yeah. Let me remove my thing here. I'm going to switch back to my browser because I can only share one app at a time. And I could probably bring up.
Sorry, I'm laughing at the pixelated artwork that Yanni posted. Sonic hat in the glizzy.
Yeah, here is the inspired thing. Let's see. Does it show up on my thing? Okay, cool. Yeah, so this is the GitHub repo from Dim, aka, and they have this AY98912 ESP32. Fantastic name. It rolls off the tongue, right? But it's basically the sound chip that was like used in arcade cabinets and other game machines to create a PT3 player. And I guess that's the native sound chip. So this is what was inspired. Lamar found this and suggested that, hey, maybe this could be a fun CircuitPython remake. But it says it uses the original AUMI library for true GRU mathematically correct. It uses double 64-bit ESP32S3, has no hardware for FPU or double causing I2S. Okay, we get it. Very technical.
Is there a picture of this?
There's no picture. I wouldn't understand what any of this means. Like it doesn't say anywhere that this is a chip tune player, right? Like
Mm-hmm.
But if you look this up on like Wikipedia or just on Google, it'll tell you is a programmable sound generator, and it's a classic 3-voice programmable sound generator developed by General Instruments in 1978. It's a smaller cost-saving 28-pin variant of the famous 40-pin AY3. People that are in that community of like old school 8-bit, processors and sound chips and stuff like that, they'll know. Computers, the Sinclair used it.
Apple II.
Little Vision, Vextrex, the Apple II, they all use this sound chip, right? And that's what the sound chip looks like. So we're basically emulating this in CircuitPython, I think. And here you can actually find Liz's code here on GitHub. Can I pull it up? Yeah, let me get that link here. You can see just a little bit of what it's doing here. So CircuitPython chiptune player uses the AY8912 emulator helper library to play VGM or video game files through the I2S DAC, and then it uses the FeatherWing for a touchscreen UI. So you can kind of read through here how it's handling it and stuff. But yeah, and then you can get video game music, right? Video game music files. There's sites on the website on the internet. Retro game music, chiptunes ripped from hundreds of games. I don't know the legality on that stuff, so y'all can figure it out.
It's old enough that it's okay.
It's old enough it's okay.
I think so.
Wiki. Yeah, video game music is an audio file format for multiple video game platforms such as the Master System, Game Gear, Mega Gear, Neo Geo, blah, 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 on and on and on. So it's a thing. Like I knew about chiptunes, but I didn't know about like the actual file formats or the sound chip and stuff like that.
I've only been exposed to the MIDI versions of these.
Me too. I only know MIDI stuff. I don't know about VGA. So it's cool. Yeah, you can still play MIDI. There's lots of remixes as prisoner. Yeah.
Remember you finding them and putting them into the floppy disk?
Right, into my piano. Yeah, I had a Yamaha PSR 630, and it had a floppy drive, and it could play MIDI files, and it was super cool.
Too cool.
Play MIDI files. That's what led my journey to like learning about MIDI music, all sorts of stuff. So yeah, pretty cool. Yeah, so that's what we're working on. Again, collab project with Liz. So maybe in the next week or two, we'll I should be able to get some parts printing on Friday, if not Monday. And that
doesn't look like you need any more components, but the framing there for the feather mounts is available if needed.
Yeah, I want to keep it like relatively simple, so not too many components, because it can get pretty hairy pretty quick. So we want to add a speaker, we want to add the amplifier, we want to add a handle. Then you're designing a boombox with like buttons and all sorts of crazy stuff, which you can do.
I had to stop myself from adding a speaker and a vibration motor on this project.
Right. Add like a real needle with a servo.
Oh, with navigation, yeah. No, with navigate like actual turn by turn.
Oh, right, turn by turn.
I mean, the thing that made me go, okay, let's see what it can do was Lamar saying, oh, yeah, just use the AI, see how far you can go and break it. So I'm like, okay.
Right. Yeah. So one last time, if folks want to pick up any of the DAC or anything, Navigator, we'll get you 10% off your order.
Light of the navigation.
All right, we got 10 minutes left. Do we want to talk about the adapter?
Yeah, real quick. Used Fusion AI to create this cool little adapter for my fisheye lens. I had to get new lenses for this project because the way that the ones that the kit that came with the Fuji, it's like the 16 to 55, but it's like a 2.8 to 3.5, and like that's not wide enough for me being able to record the handheld stuff. So I had to get like the Sigma 14 mil. I had to get the 1.2, which now I use for all my freaking shots because it's so beautiful. Like the tracking, and then being able to go to f 1.2. Like the lighting, I don't need to worry about anymore.
Wow.
So one of the other things I was into checking out is all of the lenses now, the knockoff lens, not knockoff, but third-party lenses. Before, when we were like in the Canon world, man, like we had to get a freaking Canon lens, and it was like $2,000, and like there was no way around it. There was no other people that were making lenses. This fisheye one is like $120, and it looks so beautiful. It's f2. From who is this? I forget who the brand is for this one. Is it Brayton Store? No, TT Artisan.
Yeah, so
all metal, freaking heavy, absolutely beautiful. It's manual though, so it's all, which I'm fine.
Manual focus.
You know, I come from manual world,
right?
So yeah, but it steps all the way down to f2. I think the one that we had before was a Sigma 10 millimeter fisheye for our Canons.
Yeah, but this is the Micro Thirds native, right?
I know this is X mount native for XG. But because it's so wide angle, I'm not able to. You can't use a polarizer on there, which of course you've seen. I absolutely need a polarizer for all the reflection.
Very, very sunny, very reflective.
Yeah. There was
basically sunglasses for your lens for non-photographer folks.
So I'm using an 82 millimeter Hoya, made in Japan.
Yeah, very, very nice.
Was able to reuse these. We got these like, I don't know, decades ago. So definitely
like literally a decade ago. Yeah,
or more.
Lenses last, man.
This is definitely older than Gavin, than my child.
That's funny.
So yeah, I had of course the difficulty is in creating the super thin threading that is required for these.
So you got an adapter, you 3D printed it.
I wanted to test out Fusion and be like, because again, I didn't want to sit there and make a custom thread. I asked the AI preview mode inside of Fusion. What is it? Not developer preview, the technical preview that they have going on right now. I don't know if it's going to cost money later on or not, but it was able to build custom threads using the spiral tool, which I thought it would just use the threading tool. And it made parameters for me. It holds on super. Like,
wow, that's great.
Yeah, it took a lot of iterations to get it here, but it did eventually work. And the I could have, I think I would have struggled to create it by hand. The thing that saves using the Fusion AI is at one point where I had to make the tapers on the inside and then the wall stopper so that this hits the inside without hitting the $200 CPL filter on here. At one point, I lost the tolerance on it. And I was able to tell the Fusion's AI, hey, go back to iterations before where the print came out perfect. And it was able to go back and grab those tolerance settings. So I was able to reapply it to the model that it's working on. So that's where it saved my butt, dude. If I was doing this by hand, I would have lost that and been like completely screwed, like spent even more time trying to figure out what the heck was that freaking number that I used before for building the tolerance for this. And then, building the script that's doing the parameters. So now I can just type it in. And if I ever need like a different diameter size lens, I can build it for that. And then adjusting or adding on to the tolerance so that it grips on good. Because the first couple of iterations, it felt like it was good. But then when I take it outside, I go to the parks and use it, film it, and in the sun, the tolerance is going to get loose.
Oh yeah.
So when I come back, I'm like, oh no, it worked initially, and then it came loose. So I need the teeth to be higher. I need the pitch to be, I add like a 0.1 tolerance, and then add on a 0.2 for the way that it tapers on the inside, so it holds on. Add an additional like height, so it goes beyond that. I think I even want to add like a Ninja Flex wall on here, so it even holds on to that. So super helpful. I think the saving is the AI knowing at what point I told it that, hey, this tolerance is perfect, save that. So if I add any additional more stuff to it, it knows what the numbers were on where I told it I had a successful print. And even the way that it talks, it sounds like Claude or any of the AI. So congratulating and
right.
optimistic on getting something good. I tried doing like like I was saying before, an animation of this, but it can't do everything yet.
No, yeah.
Doing an explosion for the components, but this, yeah, it's slides in, slides out. It has that wall stop, like I was saying. The threads are freaking beautiful on here. The wall stop, what I'm talking about, is just a little wall right here that catches these. I don't know what these little hood things.
Yeah.
Super simple part. It's just a cylinder, but there's very fine pitch threading on there, even for the printing. You were saying, oh, how did you print that? It's
yeah.
We're using the variable layer height, so it's at 0.2, and then once it gets right before the thread starts, it goes to 0.1 for the layer height. So it's super fine, so it's able to print all of the little teeny tiny threading that is on a lens threaded.
Cool.
And so super useful for that. For creating the parameters.
Just PLA. I think it's like the glittery PLA from like everyone.
Yeah, I need to reprint it in the silver to match that. I love the way the silver looks on.
Yeah.
These. But yeah, 10 millimeter looks so freaking beautiful. And then all the film simulations, like I got sucked into building my own recipes and like making all the ones that everybody on. So my feed is now full of all of the Fuji film simulations and utilizing all the way that it looks so freaking beautiful out. You know, you don't have to shoot raw anymore. It's just JPEG right out of there, and it looks so freaking stunning.
Nice. Okay.
The way you're using the clarity settings and like all the processor intensive film looks that it's able to do in camera, like all of the sharpening and the highlights and the shadows and the color. Oh my god, it's so pretty.
Cool. Yeah.
Speaking
of the AI, I don't even want to call it the AI assistant in Fusion. It is an assistant. Like it's not doing everything. I tried it out a little bit. I haven't figured out a good use case, but this is great to see.
I didn't have high hopes for it, but it did it. It saved my butt. Like
that's really cool.
What
a good project to try it out on too. Is like I just need an adapter, this filter to this lens.
Exactly.
These are the dimensions.
I didn't know what the threading for an 82 millimeter filter would be, so it's you see it scouring the net for reference and going, okay, we can't use the built-in threading thing. I have to make one from scratch with the spiral tool. I'm like, oh crap.
The spiral tool is the way to go.
It didn't do it perfect. It didn't know how to do it. Like it had to keep trying. So this wasn't a one and done, a two,
it's literally
20 and done, bro. This took like 2 or 3 days, I want to say, for it to get to a solid grip and just the way it goes on. And then me actually going out in the sun and testing it out with things getting loose and being scared, like, oh no, I need to put this back in my backpack because it's gonna fall off and break.
Right. All right, we got about 2 minutes, so let's quickly walk through
Timelapse Tuesday for Community Makes,
and then we'll call it.
Yeah, this week we continue with the pool themed 3D prints for Community
It's summer themed.
Yes, we have that we have a boat, balloon boat powered. I know we built one before, but this is a newer one that is on Maker World. It's balloon powered. Read the instructions where it says use a small balloon. So I tried using a normal sized balloon and it just capsized over. So just load up and clean up the edges here.
So what, there's just a channel from that kind of post to the back. Oh, it's very small.
Yeah, it's so tiny.
Yeah, and the little bubbles come out. Let's play the video here so we can see it in action.
Supports because of the way it's printed.
Right. Upward. Is that how it's meant to be print, like a 45 or?
Yeah, because the bottom has I don't know what it's called, like splits the water so it can glide. And it does tend to go in circles. So
is it a color changing thing? Is it changing colors or something? Or is it gradient?
It's gradient. Yeah, it goes from red to orange.
Yeah,
I thought it was cool for that. For filming in a pool, you can't print in blue or in green. So you always have to print something that stands out. And as I learned with a couple of the last projects, I think we did like a cricket powered boat and that blended right into the pool. So I was like, oh no. So I remembered that.
Well, the print looks great. Yeah.
Yeah.
Just PLA.
PLA didn't melt in the sun.
Is this an AI photo?
This is, bro, everybody in the comments says that. It's like, this is AI.
Yeah.
I did not, it didn't even cross my mind that this was AI, but yeah.
This perfectly generated water. Like there's no way your balloon's going to do that. But there are some real ones. Here's a bathtub. It's going to go nice and straight when you're in like calm water.
It goes in circles.
It goes in circles, yeah. Well, you think about the water displacement. It's like the waves and stuff are going to make it go other ways. Are there two designs or is it two different prints?
I think it's one. Yeah, but it looks like one has a, maybe it's the color, maybe the red.
Did you do what is this? The raft as well?
Yeah. Oh yeah, I did whatever the
settings say. Okay.
3MF was. Yeah,
it's one color. It's really good. Optimized for strength. Problems with APX printers. Let's see what people printed. People printed it. Did anyone use it?
Yeah, super fun. Cool.
Yeah, give it a try. I don't know. It's fun.
Kids liked it.
Yeah, it's fun pull toy.
The thing obviously is the water will get in.
Oh, it's not watertight?
No.
No.
There's no water in this one, but the other one I couldn't bring in. The green one, that one has water.
It has water in it.
And it will obviously affect how it floats if there's water in.
Of course.
On the inside where the infill is.
Right. Okay. Cool. All right. That is up there on Make Worlds. Free download. Check it out if you're interested in making a fun pool toy. All right, we're a little bit over time, so I'm going to go ahead and close it out. Don't forget, if you want to order anything in the Adafruit shop, please use our coupon code. It'll get you 10% off your order. Navigator is the coupon code, and it's good for the next 24 hours. Expires tomorrow on the 25th of June. All righty. Say our goodbyes on Discord. Thanks, everybody, for watching. We should be here next week. I'll have some more progress with my chiptune player, collab project with Liz. And Pedro, you'll pick something up too. I'm sure you'll have some fun stuff.
Flight tracker.
You want to do a flight tracker? Cool.
Yeah, I think Carter wants to do the code for this one.
Yeah, nice collab project with Carter.
We posted one for the 3D printing blog tomorrow. Very nice one that we'll definitely take inspiration from. It's using the round. Forgot the name of the display.
Yeah.
Qualia.
Oh, okay. Cool. All right, let's see. I won't go through all the shows, but tomorrow is JP's workshop. Tune in at 4 p.m. Eastern time. And we'll see if somebody wants to host tonight as Lamar and Phil are still off. We'll see if somebody on the team wants to host. So that's up in the air if anyone wants to host. Tonight's show and tell usually happens tonight on Wednesdays at 7:30 p.m. Eastern time. And then Friday, it's either going to be Tim, Foamy Guy, or Scott at 5 p.m. Eastern time. I think he's back this week. I'm not exactly sure. But yeah, that's going to do it. Just check out the Discord and do question mark show times for all the show times. And you'll get all the show times there.
Oh, man, check out what Do Wester posted. Dang it, that's what I should have did. Made a universal filter system for the lenses. You can just insert the squared ones. That is a good idea.
Oh, where's that?
He has it there in that link. If you click on it,
I see.
Shoot you over to what it looks like. It is it's that barrel, but then it goes into a square where you can slide in universal.
Oh, I see what you're saying. That's cool.
Yeah. I don't have any of those, but it can easily be adapted to that.
Nice. Yeah. There's a whole world of lenses. All right, folks, that's going to do it for us. Thank you so much. We'll see you next week. But until then, remember to make a great day. Bye, everybody.